A job title have access to information resources in accordance with the owner-defined controls and access roles. Users. One purpose of a security awareness program is to modify which of the following: A. Employees' attitudes and behaviors. B. Management's approach. C. Attitudes of employees toward sensitive data. D. Corporate attitudes about safeguarding data. A. Employees' attitudes and behaviors. Explanation: because people are the weakest link in any security-related process, it's crucial that a security program address user education, awareness, and training on policies and procedures that affect them. The totality of protection mechanisms within a computer system, including hardware, firmware, and software. It consists of one or more components that together enforce a unified security policy over a product or system. Trusted computing base. Reference monitor, aka abstract machine. Implementation of a reference monitor for a specific hardware base such as Sun Solaris, Red Hat Linux, or Mac OS X. Security kernel. The TCB, reference monitor, and security kernel are essential for military and government-grade information technology security to prevent unauthorized access or threats to the integrity of programs, operating systems, or data. T or F in the ring of trust. Trust in a system moves from the outside to the inside in unidirectional mode. True. T or F. Multics was the first operating system to provide a hierarchical file system. True. Which of the following terms best defines the sum of protection mechanisms inside the computer, including hardware, firmware, and software? A trusted system. B. Security kernel. C. Trusted computing base. D. Security perimeter. C. Trusted computing base. Explanation: the trusted computing base is the totality of protection mechanisms within a computer system, including hardware, firmware, and software. Process isolation. The principle of least privilege. Hardware segmentation. A TCB practice in which process operation that is divided into layers by function. Each layer deals with a specific activity. The lower layers perform basic tasks, whereas the higher layers perform more complex or protected tasks. Layering. A TCB practice in which a process that defines a specific set of permissible values for an object and the operations that are permissible on that object. This involves ignoring or separating implementation details to concentrate on what is important to maintain security. Abstraction. Data hiding, aka information hiding. A TCB practice in which parts of a computer system that retain a physical state for some interval of time, possibly even after electrical power to the computer is removed. Information storage. A type of information storage in which it is the computer's main memory that is directly addressable by the central processing unit. Primary storage is a volatile storage medium, meaning that the contents of the physical memory are lost when the power is removed. Primary storage, aka random access memory. A type of information storage in which it is a non-volatile storage format that can store application and system code plus data when the system is not in use. Examples of this type of storage are disk drives or other persistent data storage mechanisms. Secondary storage. A type of information storage in which refers to a definite storage location for a program in memory and direct access to a peripheral device. This is common with database management systems that control how storage is used outside the operating system's control. Real memory. Virtual memory. A type of information storage in which it is the computer's primary working and storage area. It is addressable directly by the CPU and stores application or system code in addition to data. Random memory. A type of information storage in which it is computer memory that is accessed sequentially. An example of this is magnetic tape. Sequential storage. A type of information storage in which it experiences a complete loss of any stored information when the power is removed. Volatile memory. T or F closed systems are proprietary in nature. True, they use specific operating systems and hardware to perform the task and generally lack standard interfaces to allow connection to other systems. The user is generally limited in the applications and programming languages available. And blank is based on accepted standards and employs standard interfaces to allow connections between different systems. It promotes interoperability and gives the user full access to the total system capability. Open system. A technique used by a system that is capable of running two or more tasks in a concurrent performance or interleaved execution. Multitasking. Permits the interleaved execution of two or more programs on a processor. Multi-programming system. Provides for simultaneous execution of two or more programs by a processor. This can alternatively be done through parallel processing of a single program by two or more processors in a multiprocessor system that all have common access to main storage. Multiprocessing. Finite state machine. A time-sharing operating system project begun in 1965 as a joint project by MIT Project Mac, Bell Telephone Laboratories, and General Electric. It was the first operating system to provide a hierarchical file system. Multics. Which of the following terms best describes a computer that uses more than one CPU in parallel to execute instructions? A. Multiprocessing. B. Multitasking. C. Multithreading. D. Parallel running. Describe what a system should do by design. Functional requirements. Describe how the functional requirements should be implemented and tested. Assurance requirements. A collection of criteria used to grade or rate the security claimed for a computer system product. The now obsolete TCSEC was often called the Orange Book because of its orange cover. Trusted computer system evaluation criteria. T or FTCSEC provided classes of trust that are roughly equivalent to object classifications of unclassified, secret, top secret, and beyond top secret using the letters D, C, B, and A, respectively. True. Division D, minimal protection. Division C, discretionary protection. A particular TCSEC class for systems that satisfies the discretionary access control requirements by separating users and data. It incorporates mechanisms that are capable of enforcing access limitations on an individual basis. Class C1, discretionary security protection. Class C2, controlled access protection. T or F security assurance divisions above Division C are usually reserved for governmental systems and are rarely found in the commercial world unless the company acts as a subcontractor to government agencies requiring such protections. True. T or F assurance levels in the common criteria above evaluation assurance level 4 are typically reserved for national government systems. True. A particular TCSEC class for systems that must preserve the integrity of sensitivity labels and use them to enforce a set of mandatory access control rules. Systems in this division must carry the sensitivity labels with major data structures in the system. Division B, mandatory protection. Class B1, labeled security protection. Class B2, structured protection. Class B3, security domains. Division A, Verified Protection. Class A1, Verified Design. T or F Class A1 systems must meet 5 important criteria for design verification, independent of the particular specification language or verification system used. True. The 5 important criteria for design verification. The Red Book of the Rainbow series. This document restates the requirements of the TCSEC in a network context as contrasted with TCSEC on standalone and non-networked environments. The Trusted Network Interpretation of the TCSEC. A European-developed criterion that fills a role roughly equivalent to the TCSEC for use throughout the European community. The Information Technology Security Evaluation Criteria. True. ITSEC assurance class that provides inadequate assurance fails to meet E1 requirements. E0. ITSEC assurance class that provides an informal description of the TOE's architectural design and functional testing that the TOE satisfies target requirements. E1. ITSEC assurance class that provides E1 requirements plus an informal description of detailed designs, testing evidence, configuration control requirements, and approved distribution procedures. E2. ITSEC assurance class that provides E2 requirements plus source code and drawings that are evaluated and testing evidence of security mechanisms that are evaluated. E3. ITSEC assurance class that provides E3 requirements plus a formal model of security policy, semi-formal specification of security enforcing functions, architectural design documents, and detailed design documents. E4. ITSEC assurance class that provides E4 requirements plus evidence of close correspondence between detailed design and source code. E5. ITSEC assurance class that provides E5 requirements plus a formal specification of security enforcing functions and architectural design along with consistency with a formal security policy model. E6. Which of the following places the Orange Book classifications in order from most secure to least secure? A. Division A, Division B, Division C, Division D, Division D, Division C, Division B, Division C, Division D, Division B, Division A, Division C, D, Division C, Division D, Division B, Division A. A. Division A, Division B, Division C, Division D. T or F. The Canadian Trusted Computer Product Evaluation Criteria is the Canadian equivalent of the TCSEC. True. T or F. The Federal Criteria for Information Technology Security was developed as a joint project by the National Institute of Standards and Technology and the National Security Agency. True. T or F. The federal criteria was an attempt to develop a set of newer criteria to replace the aging TCSEC. It introduces the concept of a protection profile that empowers users or buyers of technology to specify their security requirements for hardware and software. True. Common Criteria Project combines the best features of the TCSEC with the ITSEC and the CTCPEC and synergizes them into a single international standard. The Common Criteria, also known as ISO 15408. T or F. The CC breaks apart the functional and assurance requirements into distinct elements that users can select for customized security device implementation. True. In the Common Criteria, this element permits the expression of requirements that meet an identifiable subset of security objectives. Packages are reusable and can be used to construct larger packages as well. True. Blank work as a generic description of product and environmental requirements. Protection profiles. Blank blank are the specific products or systems that fall into an evaluation against an existing PP. The sets of evidence about a TOE and the TOE itself form the inputs to a security target that certified independent evaluators use as the basis for evaluation. Targets of evaluation. A catalog of components that developers of PPs use to form the requirements definition which is needed to consider the threats to an environment for a trusted product or system. Common criteria. T or FAPP has an intro, TOE description, and security environment with 3 more subsections. True. Audit. A class of security functional requirements in which functions are used when the TOE implements cryptographic functions in hardware, firmware, or software. Cryptographic support. Communications. A class of security functional requirements in which functions are related to protecting user data within a TOE during import, export, and storage. User data protection. A class of security functional requirements in which the functions ensure that users are associated with the proper security attributes. Identification and authentication. A class of security functional requirements in which functions are intended to specify the management of several aspects of the TOE security functions, security attributes, and security data. Security management. A class of security functional requirements in which the requirements protect a user against discovery and misuse of identity by other users. Privacy. A class of security functional requirements in which the requirements relate to the integrity and management of the mechanisms that provide the TSF and to the integrity of TSF data. Protection of the TOE security functions. Resource utilization. A class of security functional requirements in which the requirements control the establishment of a user's session. TOE access. Configuration management class. Delivery and operation class. Development class. Guidance class. Lifecycle support class. A class of security evaluation assurance requirements in which cover the testing requirements needed to demonstrate that the TSF satisfies the TOE security functional requirements. This class addresses coverage, depth of developer testing, and functional tests for independent lab testing. Test class. A class of security functional requirements in which defines the requirements directed at identifying exploitable vulnerabilities. Specifically, it addresses vulnerabilities introduced in the construction, operation, misuse, or incorrect configuration of the TOE. Vulnerability assessment class. A class of security functional requirements in which demonstrates that the PP is complete, consistent, and technically sound, and that an evaluated PP is suitable as the basis for developing an STREET. Protection profile evaluation. A class of security functional requirements in which demonstrates that the STREET is complete, consistent, and technically sound, and is suitable as the basis for the corresponding TOE evaluation. Security Target Evaluation Class. Maintenance of Assurance Class. EAL1. EAL2. EAL3. EAL4. EAL5. EAL6. An evaluation assurance level that applies to the development of security TOEs for application in extremely high-risk situations when the value of such assets justifies the costs for higher assurance levels. EAL7. A board of member responsible for producing an agreed-upon methodology for conducting evaluations to apply the CC to security targets. Common Evaluation Methodology Editorial Board. A companion document to the CC. It focuses on the actions evaluators must take to determine that CC requirements for a TOE are present. It is an evaluation tool to ensure consistent application of the requirements across multiple evaluations and multiple schemes. Common Evaluation Methodology.